So when you're asked to determine a remainder, you can now do it in one of two ways. You can use the remainder theorem. So if I use the remainder theorem, that says I can just plug in 3 into my original equation. And 2 times 3 to the 4 minus 5 times 3 cubed minus 5 times 3 squared plus 5 times 3 plus 3 is equal to what? Well, that would be 2 times 81 minus 5 times 27 minus 5 times 9 plus 15 plus 3 would be plus 18. 162 minus 135 minus 45 plus 18, 0. Nice. You have to decide, was that more mental math than I would like to do? Are some of those numbers too big? This is using the remainder theorem. The other thing that you can always do to find out a remainder is actually to use synthetic division. Well, for synthetic division, the number outside would be a positive 3. And when we look what we're dividing by, it's already in the right order. So for setup, that's good. And there's nothing missing, goes from degree 4, 3, 2, 1, 0. So as far as setting it up, you don't have to remember any zeros. Wow, that's a funny looking 5. 5 and 3. And your synthetic division looks like this. Bring the 2 down, multiply, add, multiply, add, multiply, add, multiply, add. In this particular example, I feel like the synthetic division was quicker than the remainder theorem. Plus, the biggest number I had to multiply was 3 times 2, which I'm really good at that. I know that that's 6. The biggest numbers I had to add or subtract were like 6 and negative 5, which isn't too bad. Whereas the remainder theorem here, the biggest numbers I had to multiply were 3 to the 4, or 2 times 81, or 5 times 27. Those are all pretty big numbers. And then I had to add and subtract all of them. So in this case, I would say that the remainder theorem is nicer. Plus, the remainder theorem also tells us the next step. Not only do we now know that x minus 3 is a factor, we now know how to factor this. So if I start with 2x to the 4 minus 5x cubed minus 5x squared plus 5x plus 3, I know that I can factor this. It factors to x plus 3 times, and the answer is right here, 2x cubed plus x squared minus 2x minus 1, because the remainder is 0. So your division statement helps you factor it. We just factored that. I don't know if we're done factoring, because this here might be able to factor further, but we've started factoring it. For the second one, same thing. We could plug in negative 2 into the whole thing and see if it works. Okay? Just looking at the sheer volume of things that we have to plug in, I'm thinking the synthetic division might be a quicker method again. So for the second one, we're going to go right to our synthetic division. It's going to be negative 2 here. Again, it's 2, negative 5, 5, 3. Bring that down, negative 4, negative 9, 18 plus 13, negative 26. Ooh, see, this time the numbers got bigger. This time we got a remainder of 45. So what do we know? We know that this is not a factor. Okay? As far as questions, oh, there's still a C and D. No, I'm looking at the wrong one. There's just those two. You can now do 4A, 6A, 7, and 8.